In this video, we are going to look at special binomial expansions. First, we will look at perfect squares. Now, if I have to simplify 3 squared, I can write 3 times 3. Similarly, I can write a plus b squared as a plus b times a plus b. So, which is product of binomial expression. And we have already learned how to expand. Split the terms of the first parenthesis and times them with each term of the second parenthesis, or other way around. That gives a squared plus ab plus ba plus b squared. Ab is same as ba because of commutative law of multiplication. What that means, 3 times 4 is same as 4 times 3. So you can combine these two terms. AB plus BA is 2AB. So that gives you A squared plus 2AB plus B squared. How I remember, I write the first term square. Then at the end, I write the second term square. In the middle, I write 2 times the product of first term and the second term. Also, you need to remember this sign is same as the sign in between the two terms in that square parenthesis. We can also prove this by area diagram. If you look at on the right, we have a square with side length a plus b. Each side can be divided into two parts of lengths a and b. So that divides square into 4 rectangles. A plus b squared is represented by the area of square with side length a plus b, which is same as the sum of the areas of these 4 rectangles, which are calculated as a square, ab, ba, and b square. And if you add them, you get the same result. Now we are going to look at a minus b squared. Again, you can write it as product of a minus b and a minus b. Split the terms of the first parenthesis and times them with each term of the second parenthesis. And remember, you also need to include negative sign with b to expand the second term. So that gives you a square minus ab. And when there is a negative number outside the bracket, parenthesis, the sign inside the parenthesis will change. So that gives you a square minus ab minus ba plus b square. And again, ab and ba, they are like terms. So combining them, it gives you a square minus 2ab plus b square. So again, how I write a square plus b square. Then in the middle, I write 2 times a times b. And the sign will be same as the sign between the two terms between a and b. Now to show this by area diagram, we draw a square of side length a. Then take away a length of size b. Then the remaining lengths are a minus b and a minus b. The shaded area of square side length a minus b represents a minus b whole square. Now how to find this shaded area? In this case, it will be easier to take it as area of outer square, take away unshaded areas. So if you look at here, from a square, you subtract all the areas which are unshaded, combine the like terms, and you again reach at a square minus 2ab plus b square. In this case, it's harder to manipulate than algebraic manipulation. Now, we also need to look at difference of squares. A minus b times a plus b times a minus b. Split the terms of the first parenthesis and times with the terms of the second parenthesis. So that gives you a square minus ab plus ba minus b square. A minus ab plus ba cancel out. and we are left with a square minus b square. This is easy to remember. How to show this by area diagram? Draw a rectangle with side length a plus b and a. To represent a minus b, take away a part of that side of size b, and then the remaining is a minus b. Then the shaded area represents a minus b times a plus b. And you can find out area of each shaded rectangle, add them by combining like terms. That gives you a square minus b square. So in summary, we have learned three formulas: a plus b squared, a minus b squared, a plus b times a minus b. Now, how to apply them? Expand and simplify. Part A, 7y plus 2z squared. It's easier to work with it if you set it out first. I use parenthesis square plus 2 times parenthesis parenthesis and then parenthesis square, and then I fill them up with the terms. So 7y squared, and then I first write on the second term square, then 2 times 7y times 2z. There will be less chances of errors if you use the parenthesis. Now 7y squared, if you want to remove the parenthesis, it will be 7 squared y squared, which is 49y squared. 2 times 7 times 2, 28yz, and then 2 squared z squared, that gives you 4z squared. Now these are unlike terms, so that's the final answer for this part. Part B, 2 minus 5a squared. Compare it with a minus b squared. Again, set it out. So first term square, the last term square, in the middle, minus 2 times first term times second term. Now, fill these parentheses. 2 square, 5a square, in the middle, 2 times 2 times 5a. And remember, this negative sign goes with the negative side between the two terms. Now simplify. 4 times 5, 20a, plus 5 square, 25a square. Can't be simplified further, so we leave it here. Part C, ab plus 8c times ab minus 8c. This looks like difference of squares. So set it out first. ab squared minus 8c squared. And if you want to remove the parenthesis, so it's a square, b square. Take away 8 square is 64, c square. Part D, it's combination of perfect squares and the difference of squares. So set it out for the first term, and then set out for the second term. The first term is a plus b squared, and the second term is the difference of squares. So fill the terms. So 2h square, 3 square, 2 times 2h times 3. Here 2h square minus 3 square. Now simplify it further. 2h whole square is 4h square. 4 times 3, 12h, plus 9. Take away 4h square minus 9. You still need to use the brackets. Now here I'm using brackets, the square brackets. Now we need to remove those square brackets. So that gives you 4h square plus 12h plus 9. Now because there is minus sign before the bracket, the sign inside will change. Now you can cancel and combine the like terms. That gives you 12h plus 18.